Hello everyone. In this video, we will take a look at valid anagram problem. In this problem, basically we have to check whether two strings S and T are anagrams of each other or not. Anagram is a word formed by rearranging the letters of different words and typically using all the original letters exactly once. So, for example, if S is equal to anagram and T is equal to Nagram, in this case, our output should be true because these two strings are anagram of each other. So the strategy here is very much straightforward. Basically, we have to check whether the character counts. So in this string, the character counts of each character are equal between these two strings or not. As in the constraint, we are given that both of these strings consist of lowercase English letters. So what we do here is we can take an array of size 26 and basically we can go on incrementing the count while iterating over the characters of first string, and we will go on incrementing the count. So basically when we encounter A, we will make this from 0 to 1, then n, we increment the count for n and so on. So when we are finished iterating over our first string, after that what we do is we start iterating over our second string, and we go on decrementing these counts. So first is n, so we decrement the n and n becomes 0 again. uh, a a becomes 2 and so on. And once the iteration is complete over second array as well, what we will have to check at in the end is whether this character array, which is 26 of size, whether all of these places are filled with 0 or not. If any of these place is non-zero, that means we have unequal counts between the characters of string 1 and string 2, and hence in that case we return false. If all the characters are 0, in that case we should return true, as both the counts both the counts of characters in both the strings are equal, and hence both the strings are anagram. So if we take a look at code, basically we are accepting string S and string T. We initialize our chars array with size 26 because we have 26 lowercase English letters. Now ASCII value of our lowercase English character A is 97. So basically this will be used to map 0th place for A, because we can subtract 97 from any character to go to get in this place, in this range. So now we start iterating over the first string, and at the respect at the corresponding or at the corresponding space, we increment the count by 1, and once this iteration is complete, basically as we saw earlier, the character counts will be filled with the appropriate counts. After that, we go on iterating over our second string, which is T, and at this time for the corresponding spaces, we go on decrementing the counts by 1. And at the end of iterating over this character array, second string, we should be expecting that all the character counts in our chars array are 0. So if we encounter any non-zero character count, in that case we return false. And if we successfully iterate over this char counts where all the character counts are 0 in this chars array, in that case we return true. So overall time complexity of this solution will be O of n, as we are iterating over these two string character arrays one by one, and let's say n is the total number of characters in this string. As we have these two for loops, not nested for loops, and that's the reason the overall time complexity will be O of n.